Okay, so we're trying to find the derivative of inverse sine of 5 raised to the secant of x. So this is a case for the chain rule, of course, because we've got a function of another function of another function, right? And so the first thing we have is the most outside function is inverse sine. So we get the derivative of that one first, which is 1 over the square root of 1 minus, now its derivative of inverse sine is square root of 1 minus x squared, but since we have other stuff, in this case 5 to the secant of x, that has to stay the same. So it's the inside is being left alone, and then you square it. Okay? And then you're going to multiply that by the derivative of the inside. Now here, you have a function of a function as well. So you pretend like the inverse sine doesn't exist. Now we're just working in here. The derivative of 5 to the secant of x, well, the derivative of 5 raised to any power is itself, leaving the inside alone, times natural log of the base. But then you have that inside, and you have to multiply by the derivative of secant, which is secant x tangent x. And now we're done. Okay, let's do another example. Okay, so let's say we have the function x over x plus 1, and we want to evaluate the derivative of the inverse at x equals to 1/2. Now, what we need to do is we need to use our formula, so let me write down the formula so that we have it. Okay, so here's our formula. So we need to find a couple of things. Let's write down the, right here, let's put down the steps. So the first thing we realize is we're going to need f prime of x. So let's do that. Let's find the derivative of f. Now, we should notice, I'll let you know that for functions like this that actually have an inverse, that you can find a, that you can find the inverse for easily, the inverse function, you can do that as well. So another option for what I'm doing right now is to find the inverse of this, which is relatively straightforward, and then find its derivative and plug in 1/2. So you can do that, but and you can compare it to what we get. But we're going to do it using this new formula that we derived, because a lot of times you can't actually find the inverse function. We're going to find the derivative first. So the derivative of this guy, notice we have to use the chain rule. Sorry, the quotient rule, because we're dividing. Okay, so if I use the quotient rule, I'm going to have 1 times x plus 1 minus the top, which is x, times the derivative of the bottom, which is just 1. So I'm not writing it down. I guess you can put 1 here, because those are the derivatives. And then over x plus 1 squared. Okay, so if I simplify this, I would get 1 over x plus 1 squared. Okay. Now, so this is the derivative. Now, the next thing I need to do is find f inverse of, in this case, so my x value, 1/2. So I'm going to, this guy right here, this should be an actual number. So I need to find what the inverse is at 1/2. So, you have, the problem is that you might not have the inverse function. Of course, you can actually find it using this guy, but you're just looking for it at one particular value, the value of 1/2. So essentially what you're saying is if this guy right here, so if you think of this guy as y on the original, so on the original function, what is what is the x value that corresponds to that y value? So that's really what this is saying. Well, for this one you can actually solve for it, but let's do a little practice just using guessing, because in other ones where we can't actually solve, we're going to have to do a little guess. So notice that if x is equal to 1, then this is equal to, the whole thing is equal to 1 over 1 plus 1, which is 1/2. So the answer to this is equal to 1. Okay, so when the problems get more complicated, this is what you're going to have to do. You're going to have to guess. Okay, so then the next step, let me leave that formula here. So notice that I found f prime, and I found f inverse of 1/2, which is this guy. So then what I have then is the derivative of f inverse of x, and I'm going to put it in common notation right here. So if you put a vertical line like this and you write x equals to 1/2, what you're saying is that the derivative of this function evaluated at 1/2. Okay, this is equal to, if I just grab it from the formula, 1 over I'm going to leave this one alone, f prime at, and in here is the number that I got from this, which was, remember, 1. And so this is f inverse at 1/2, which was equal to 1. Okay. So essentially what that's saying is that I'm going to plug in the number 1 inside of f prime, which you found earlier in step 1. So let's write step 3. So I'm going to say I'm going to plug in the number that I got from 2 into the formula. So I'm going to plug it into the formula, and that's going to give me 1 over. Now f prime is, actually, why don't we do this? Instead of plugging it into the formula, let's plug it into the derivative. That'll make it, sort of break it down the process a little bit better. So we'll plug it into f prime of x. Okay. So over here, what I'm gonna do is I'm gonna find f prime at 1. So f prime at 1, so right here, this is step 3 that I'm doing. I'm plugging 1 into this guy, so that would be 1 over 1 plus 1 squared, which is 1/4. Okay. And then I can say that step 4 is we're going to plug in the number that we get from 3 into now the formula. So I just broke it down one more step. So then the derivative is going to equal to 1 over f prime of 1 is equal to 1/4, and so then this is equal to the number 4. And so that's the value, and notice that if you want to try it, find the inverse of this function, then find the derivative of that function and plug in 1/2, and you'll notice that you'll get exactly the same number, 4. Okay, so here we have another example, and this is an example that you can't actually find the inverse function of this because there's no way to solve for x. So we want to find the derivative of the inverse of this function evaluated at 1. So the only way to do this is to use this special formula. So let's do let's follow our steps. So let's start off by finding f prime of x. So the derivative of this function is e to the x plus 1. Okay. Now the second step is find f inverse of, it's not really 1/2 this time. This time it's f inverse of 1. Okay. So let me erase this guy. So what's f inverse of 1? Well, my eraser needs to get bigger. Anyways, okay, so to find f inverse of 1, what that's saying, remember, is if this guy is equal to 1, what's the x value? Now remember I told you last time you were going to have to guess on some of these. This is an example where you can't actually solve for x if you plug in 1, so we need a guess. Now, it has to be relatively simple to guess, otherwise it's impossible to ask you to do it. You can also do it using a graphing calculator, but there's no need for this one. Notice that if you plug in 0 for x, you get e to the 0, which is 1, and this guy is 0, so what that means is that f inverse of 1 is equal to 0. Okay, that's good. So we've done step 2, so f inverse of 1 is equal to 0. Okay. Step 3 is to plug the number that we got from 2 into f prime of x. So this number that we got, 0, we're going to plug it into f prime. So f prime of 0 is equal to e to the 0 plus 1, which is 2. Okay, and then step 4 is to plug in the number that we got from 3 into our formula. So the formula is this guy right here. So basically what we have is the derivative. So I'll just put right here, step 4. The derivative of the inverse function of x evaluated at 1 is going to be 1 over 2. Because this guy right here, this corresponds to f prime at f inverse of x. And so that's it. We're done.